I'm going to cover this video now on the Google Cloud platform that really focus more on how to configure or designing your network security to meet a given business requirement. It is very common to implement an application in a single project in Google Cloud Platform, but in many large organizations, even a medium-sized organization, that is not realistic. In many cases, you're going to need to have a multi-project approach that allows teams from different, sometimes even location, to collaborate together and use services that is applying or existing in a kind of a given project. This lab is going to go through how you can evolve from a simple to a very complex network configuration. We're going to look at the firewall configuration, how you can modify your firewall to manage where you want traffic to go. We're also going to examine the latest features of firewall for more precise and flexible control of your network connection. And in addition, and I hope we have the time in this lab, I'm also going to demonstrate how you can use your environment and configure what I will call a network address translation. It's a special type of router that sometimes allow your machine or your internal network system to go into the internet with more of a mask IP address. We're going to look into this a little bit later, but essentially I'm just trying to tell you that when we finish this lab, if we have the time, we're going to be looking at a NAT configuration, and that will show us how to use routes in our compute engine. I've opened two sections here, as you can see. That's because I'm going to be using this other tab to show you the effect of what we're going to be doing throughout the lab. The first thing I'm going to go ahead and do is to activate my Cloud Shell, and I'm going to bring this up as possible. And then once we do that, I'm going to go ahead and create a couple network. If you want to look at already from here, you could see that right now I have just one network. I have just one network here, and it's a default network. Really, see, that's it. I only have just one network, and it's a default network. So I'm going to go ahead and create additional two more network. I'm going to try and use a command line throughout this process. Of course, I can use a GUI to do the same thing, but I'm going to use command line. And what this does is a gcloud, okay, and I'm calling compute because network is one of the compute resources, and I'm saying create a network called Minneapolis, and I'm putting it in auto mode. If you look at what I have over here, you look at this, you can see the mode here is auto, and essentially I'm doing the same thing over here by saying I want the mode to be auto, which means Google Cloud Platform is going to automatically create all subnet for all the regions, and it's going to automatically assign IP address. It's a really neat feature, so I'm going to go ahead and do that. And then after that, I'm going to go ahead and create another network. I'm going to, this time around, I'm going to do it for Rochester. You can call it any name you want. I'm just I live in the Twin City here, so it's a little bit easier for me to adopt the name of a city that is nearby here. So I'm going to go ahead and create a subnet, and I'm going to call it Rochester, and then we're going to go from there and take some additional steps as well. Alright, so we're done with that one. That one is created. I'm going to go ahead and create another one, and you can see this is my Rochester network, and I'm actually saying I want to make this to be custom. And here we are. We have custom created, and because it's custom, if you take a look at this right now, I'm going to refresh this page here. You will quickly see the big difference here. You can see my default, and here's Minneapolis. You can see how this is created. But look at my default Rochester here, that because it's custom, I have to create for each of these regions manually on my own. and I'm going to have to set up the network address, the subnet mask, and everything. It's manual. So I'm going to go ahead and do just that, but I'm only going to be doing just for one region here. Still for network Rochester, for Central 1, and I'm specifying my network address range, and of course I'm going to enable for private IP Google access. Press enter, and this will take a couple of seconds to a few minutes. Alright, so here now we're going to go ahead and create this Google Cloud now, and I'm going to use, now you can see my command is a little bit different now. Before, when I said Google Cloud Compute Network, now I'm creating instances, which means now I'm creating virtual machines. And I'm creating the first one, I call it lab VM. I'm putting the central one, and I'm putting it in the default network that I showed you earlier. And now this is something very interesting. You can see now, if I just run this without this section, what is going to happen is it's going to create a default image for me, which is going to be Debian, and I don't want that. So that way I come over here and I specify my image family, which is Ubuntu 14, and then I specify the image project, which is Ubuntu OS Cloud. Now press enter here, and it's going to go ahead and create a virtual machine for me with this guest operating system on it. So now one of the VM is created. I'm going to go ahead and create another VM, but this time around I'm actually going to create a second VM in another network, and here now I'm putting this VM inside Minneapolis. Same operating system. So here we go again. We're going to wait for a couple minutes. As you can see, creation of VM do take a little bit of a little longer than other process, because actually creating a virtual machine. Now you can easily monitor what's going on here. As you can see, the image that we create, the subnet for Rochester that we create is right over here. I must mention something though. Everything is in small caps. If you try to use capital letter, you're going to get an error message. And I can monitor the VM that is being created by coming over here on my system. And you will begin to see now that Minneapolis that we just ran now is in the process of being created. That's kind of quite interesting for you to kind of monitor and to see this thing has been created. That's why I created two tabs, so that I can see what I'm doing over here, and that one is already done here. So the next thing that I'm going to do now is I'm going to create another machine, another VM. Create another VM here, and this time around I'm going to put it in the same environment, in the same network environment. You can see over here, this is G-Cloud. I'm putting it, I'm calling it Minneapolis 2 now. The first one I have is Minneapolis 1, Minneapolis 2, in a different zone, however, and that one is also done. That's rather quick. And then I'm going to create another VM yet. And I'm going to call this one, as you can see, I'm putting this one in Rochester network. Okay, that's a subnet, Rochester subnet that we created earlier on. And I'm calling it Rochester Bastion. And that one is going to go ahead and run. And then the next one we're going to do, and this is going to be the last VM that I'm going to create, it's going to be also in Rochester subnet. Again, you can always come back over here and see what we're doing on this other side, take effect on the other side here. It's really interesting to watch if you have a 2-tab. So it's going to take a few minutes, and then we're going to create one more yet, and then we're going to go to the next stage. And that's done. And finally, we're going to create this other one, and I call this one, this machine here, if you can see that, I call it Rochester VM. Press enter here. So now you can see that we've created and completed this process. Now we have VMs, 5 VMs in all. This one is in the default network, and these two are in the Minneapolis network, and this other one are in the Rochester network. One of the things I'm going to quickly show you right now is I'm going to try to connect into the VM in my default network through SSH, and as expected, I should be able to connect to it very easily. And I would explain to you why this is possible. Even though I've not configured anything, you can see now I have access to it. That is because if you look at the firewall rule for the default network, by default, you have these rules that are already created for default. You can see you allow HTTP, you allow ICMP, that means I can ping. He allows RDP, and he allows SSH. Allow me to do all this. But for all the other networks that you created subsequently later, they do not have an entry. Actually, they do have two entries by default. The first entry is to allow all, external going traffic and to block all incoming traffic. All outgoing traffic will be allowed. All incoming traffic will be disallowed rather. So if I come over here then, and I will test this theory so you could actually see, it's actually not a theory, it's a fact. I'm going to click, so you can see how I was able to log on to my, lab VM, which is this VM here. I'm going to try and do the same thing for this VM, for the Minneapolis. Knowing that Minneapolis, takes place in my network that I created, and you would see it's going to try to attempt to create, and if there's no rule to allow, it's going to block by default. There's no explicit rule to allow. There is implicit deny that it's that is reflected. So you can take a look at it. It's going to try to connect, and you're going to see very quickly now that see, it's saying we are unable to connect to VM on port 22, about possible whatever. We know the reason. That was because there's no firewall rules to allow these VMs to connect. And you can do the same thing for all these three other machines. You will have the same experience. So having said that, we're going to go ahead. I'm going to clear my screen here now. Having said that, we're going to go ahead and create a firewall rule for the Minneapolis network, so that VMs can be able to communicate on that port. So I'm going to go ahead and do that. And as you can see, I'm creating a firewall rule. So I'm creating my firewall rule, and I'm calling Minneapolis allow secure shell. You can look at my firewall rule name, that the name is intuitive. Very important for you to remember that. If you write a firewall rule and you use a name that is not intuitive, that's going to be very hard for you when you're trying to audit it or go through it later. And I'm saying this is for Minneapolis network. What I want to do, the action is to allow, the direction is ingress, incoming traffic, and the rule is for port 22. So I'm going to press enter now. We're going to wait a little bit. You can see it's creating the firewall rule. And as soon as that is done, we're going to test and make sure that the rule actually works as expected. And there we go. That has been done. We're going to go over here, and I'm going to do the same thing again that I did earlier to see if at this time I'm able to actually connect. This is an important step in order for us to make sure that we understand this rule. We're going to go ahead, once we are done testing this, to create some other additional rule. And now you can see I can actually connect now. And I'm going to click Minneapolis 2 as well, because I want to demonstrate other scenarios as well to you. This is Minneapolis 2, this is Minneapolis 1, and I'm going to verify my IP address here on the Minneapolis 1, and you can see the IP address on Minneapolis 1 is this. I'm going to ping Minneapolis 1 from Minneapolis 2. As you can see, I'm not able to ping. Again, because there is no rule in our firewall that says allow ping to go through. That's ICMP. So what am I going to do? I'm going to go ahead and create a ping rule, ICMP, to allow it to go through. So here we go again back to our network here, and I'm going to enter this rule. And as soon as I do that, I'm going to try and test our theory here to see if it's going to work. Again, it's creating the firewall rule here. And now you can see now it's beginning to go through, because now there is an entry that allows this to work. A very important lesson for us to learn there. One more thing I'm also going to do, I'm going to allow all traffic that is coming from a given network to come in. You can see here, this is Minneapolis allow internal, in other words, create Minneapolis allow internal, every internal traffic on this network to allow direction, ingress, rules, all rules. And that's the network that I've specified over here. And I'll press enter. This is an important step, and it's important for us to kind of realize the importance of this rule. Again, now every internal network can kind of send back and forth any traffic between the two of them. This is very, very important. I'm just going to go ahead and do the same thing for the other traffic. One thing you can do if you want to see all the rules that we have, you can simply just come over here and type gcloud, better compute firewall rule list. And if you run this, it's going to show you all the rules that we have, both for default and both for Minneapolis. If you want to filter, just want to see the Minneapolis rule, you can actually come over here and run this, and it's just going to show you the one for Minneapolis, because I have actually applied a filter that will let me see only what I want to see. All right. Having said that, I'm going to go ahead and do the same thing for Rochester. Again, this is just a repetition, so you don't really have to pay a lot of attention to this one. I'm just going to go ahead and do what I did for Minneapolis and do the same thing for for Rochester, so that we can move on to the next stage of our lab. So as you can see now, it's already displayed. The next thing I'm also going to do here is I'm going to enter another rule here that's going to open port 22 on the Rochester. Again, this is what we've done before, so this should be very, very familiar to you now. There you go. As you can see, that one is gone, and then the second to the last one is here. We're going to enter another rule here. Again, very similar to what we did earlier on. That will allow, all Rochester machines to be able to talk to one another. And of course, that should work just fine, as we have highlighted, before. All right, so we've completed that. One other thing that we can do, just to show you how granular we can get, as you've noticed earlier on, that these two machines now, they can talk to each other now, and they weren't able to do that before. I can actually write a rule that will actually prevent this machine from pinging this other one. So even within the network, we can write a rule that will prevent a machine from being able to talk to another one. So it's not just a blanket, we can actually slice and dice this last rule that we wrote here that gives everybody within this network to talk. We can actually slice it and kind of like, reduce and, minimize the broadness of that rule. For example, and I'll do this for the Minneapolis network, you would see, let me clear this up. And I'm going to go right on this one. And what this one will do is to write a deny ICMP, for Minneapolis network, action deny direction, that's egress, which, outgoing, and it's going to prevent anything that is heading to this one, to 10.132.02. Before I do that, I'm going to actually try to demonstrate that so we can actually see what is it I'm talking about. So here this machine that is pinging now, right? It's still pinging. That's what we did earlier on. I'm going to stop it for a second because I want you guys to. So now you can see the command is I'm actually going to ping this machine. And actually, let me figure out the IP address of this one. ipconfig. So, gonna do this. And I'm going to ping this guy. Now see that's working just fine. If I go back and implement this rule, anything that is destined for this network may not work. We're going to test it. We're going to go back to this that is we're checking now. The keys for us to kind of see, you can see now it's stopped. Stopped. Because of the rule we just wrote. Everything destined to this network now is now currently being blocked. So it's very, very important for us to kind of mindful of the powerful effect of some of these rules, that we have now. And if you want to see your deny rules, because sometimes when you're troubleshooting the network and there's a problem, that's one of the things you would like to see. You can actually try and see how many network is being denied, how many deny rules you have, and you can see we only have one from here. All right, that's pretty nifty. That's very important exercise for us to do there. Now the next thing I'm going to actually have us do is I'm going to move on to these last two system here. So as a result, to minimize my windows, open windows, I'm going to close these guys. I'm going to grab these guys and I'm going to close it temporarily, at least for now. And then I'm going to go ahead and open my Rochester Bastion host here. And once I open it, I'm going to try and secure shell into my Rochester VM. This is my Bastion and this is my Rochester VM. Now, one thing you have to remember, if I type the host name, you can type the host name to find out the machine name here. Host name. Now, if you try to ping this machine directly, it may not respond because we're not having DNS configured in this environment. So the machine may not know it right away. But if I run against ifconfig, I can enter the IP address of this machine. And you don't need DNS for that. So that should work if you don't have any rules blocking it. So that works just fine. So I can easily do that. Alright, so having established our connectivity, I can easily SSH into my Rochester VM here over here. SSH. Okay? And I press enter here. Press enter. It's asking me, do I want to connect to it? Now you can choose to connect, and if you do that, now you can see I'm now inside Rochester VM. Alright? You can run some stuff over here, and you can see the IP you have over here is the IP you have over here. I'm no longer inside this place again. You can exit out of that, and now I'm back inside the Rochester Bastion system. Very, very important, really nifty, cool stuff. Again, I'm just trying to kind of verify that I have some connectivity here that I can, from here I can connect to this machine. Other thing I'm also going to do is I'm going to ping just to demonstrate that I have access to the internet from here, from my Rochester VM. I'm going to go ahead and actually I'm going to clear my screen here now. Let me go ahead and I can ping Yahoo, for example, shows I have access to the internet. That's really what I want to establish. And I'm going to ping Star Wars. And you can see I have Star Wars as well. Alright, so it's good. I'm going to clear the screen up here. The next thing I'm going to also do is to, run a curl against the head. And one thing I wanted to see here really quick is that the head command is very common, especially in the security environment, because sometimes you want to kind of find more information about the web server, but you don't want to be logged on either the firewall or the security log for that web server as having contacted it. Head command, when you run it with curl, allow you to find more information about the web server without actually connecting directly to the web server. Now you can see I have access to the internet. I'm also going to run the Google storage utility to browse a remote directory. And this is Google GS, Google Storage Utility LS, to list what is in this directory. And you can see this is what I have in this directory. I can actually display what is inside this directory as well. Come over here, display what is inside this directory. As you can see, this works just really great. One thing I'm actually going to do that I want you guys to kind of pay a little bit of attention is I'm going to configure a NAT connection, a network address translation. And the only way that I'm going to be able to demonstrate that is to take this guy off of the internet. So let's see how I'm going to do that. Okay, so in order for me to demonstrate how NAT will have effect on this machine, right now these guys have access directly to the internet, so it doesn't need NAT. So I'm actually going to remove this guy from having access to the internet. Remember, so far I've been able to kind of run all this exercise and I was able to connect to the internet from this guy. So what I'm going to do is to go to this Rochester VM. Go to Rochester VM here. Going to select it. Going to edit it. And I'm going to go to the network aspect of this. And what I'm actually going to do is I'm actually going to remove the access that this guy has. See the network interface here? I'm going to select this and look at it. This is internal and this is external. It is this through this external port here, or external card here, that this machine access the internet. So I'm going to come over here and drop this and say none. By doing this, I'm going to say done, and I'm going to come down over here and click save. By doing this machine will not be able to get on the internet anymore. As a matter of fact, this window will more or less freeze up on you. You can try to do some stuff on it, but it's not gonna get you any far. You can see it's frozen. Okay, it's no longer active because the external card through which this SSH interface is established has been removed. And if you look at the signal, the direction over here, go at the VM instance here, you can see that the SSH button here has been grayed out. So the next thing you're going to do over here is I'm going to test some things and just kind of remind you earlier. Remember that earlier I was able to SSH into this box, right? Well, let me try that again. Same thing over here. You can see permission denied. Because now all of a sudden, this port has been disabled. External port through which you can reach this guy has, essentially been removed. So that does not work anymore. And even if I try to go to that particular window, it's just not going to work. That window actually gets frozen out. And if you try to access anything there, you may not even be able to do that. So it's very important for us to kind of make sure that we know that this machine, for some practical purposes, is no longer what it was before. Permission has been denied, we lose access to it. So then what do? The next thing we're going to try and do is to see how can we configure a NAT that will allow this machine to work and give us access to this, to this system. I'm going to go ahead and configure the NAT gateway. Okay, I'm going to create a NAT gateway, and I'm going to show you how the NAT gateway is going to work. The first thing I'm going to do is I'm going to tag this Rochester VM. I'm going to go ahead and tag it. Minimize this one for now. Go ahead and tag it. Okay, press enter. And you can see I'm adding tag. Rochester VM is still in the same zone. Central F now. And then I'm saying tag and I'm saying NATME. And then the next thing I'm going to do is to go ahead and create a NAT route. Create a NAT route and tell the route where it's going to take. Here I'm actually saying go and create a NAT route on a Rochester network. Okay, and I say the destination range is any network, any host. Now I'm saying the next up. In other words, the next up will be Rochester Bastion, which is this machine, this one over here. Okay, as the next up. In other words, anything that is destined for this guy, send it to this one. And the next up after that will be the the interface for this particular region itself. So essentially what you're actually doing is you're saying this is the way to get out anything that is destined for Rochester VM, because the external interface has been removed. Well, we're saying just send that traffic to this guy, to this Rochester Bastion, and then send it to this next up, and that's how you're going to route it out to the internet. Pretty nifty. So now I have configured traffic to be sent to, Rochester Bastion here. Now I need to tell Rochester Bastion itself that anytime a traffic is sent to you that is not meant for you, just please forward it. Otherwise, this guy will not know what to do with it. So the first thing I'm doing over here with the Bastion itself is to say, come on over here, as a forwarder, and then I'm going to create an IP table. Okay, an IP routing table here, and here is it. Done. And then at this point I can actually test my theory. I created just an ordinary VM. I'm going to use it because this guy is going to be acting more like my forwarder now, and I'm going to use this VM as my as another VM that I'm going to use to test the connectivity of the Rochester VM. As you can see, Rochester VM has no external IP anymore, so it's not going to be able to get on the internet at all. So let's test to see if our forwarder here is actually working correctly the way we had that configured to work. So you can see this is my fun VM. I just created it, and I'm going to clear up the screen, and I'm going to try to connect to Rochester. As you can see, I'm trying to connect to Rochester on the internal, and the ideal thing is when I try to connect to it, since the external has been disabled, the only way this is going to work is that this guy is going to connect through SSH internally, and there you go. I'm now connected to Rochester VM. As you can see, this is Rochester VM now. All right. If I type ifconfig, see, that's my IP address. If I exit out of it, I'm back where I was before. If I type ifconfig now, I'm on my machine now. This is 10.0.0.5. But if I go back and SSH into Rochester VM, if I run my ifconfig again, now you can see I'm inside, this machine. Now let's test to see if our routing is actually working the way we have designed it. I'm going to try and ping the Star Wars that I pinged earlier. Go over here. Gonna do this, and now you can see I can ping, the internet from Rochester VM that have no external connection. You can see external IP is none. How is that happening? It's sending a route through this bastion host, who is then forwarding it, to the zone gateway router as the next stop. Okay, so that is actually us demonstrating, and we can do a couple of other tests that we've done in the past, in the previous lab or stages. As you can see, I'm able to run curl against these. I'm able to run curl again against another URL, and then blast. Everything we did before, we can go ahead and do it now, and you see that everything works just just fine. Trying to see, able to check the content of a Google Cloud storage, and then press this again. As you can see, I'm able to look at what is in there. Pretty much everything that we try to do, we were able to kind of get this to work as expected, and that generally tells us, as you can see, if I want to look at my core, IF, configuration, you can see it's 35, 193, 28, 213. Whose interface is that? You can see that is the external interface of Bastion host. So that exactly tells you where this information is traveling through. That all this interface now is no longer going through Rochester VM, and this is Rochester VM, as you can see at the top here, and if you can see also Rochester VM here. Well, information is not being routed through it. The information is being routed through the Rochester Bastion host and this. And one important thing I need to let you know, there are some cases where after you've configured your NAT routing information, you might need to create another VM to use it as a test, as a VM that you want to use to connect to the Rochester VM. That's what I did in this case. There are times sometimes you get a permission denied for public key, and that will just easily solve that problem for you. Thank you guys. Hope you learned one or two things through this video. If you have any question, send me an email. Thank you.